Welcome to Intel Edge Software Hub training. In this video, we will show you how you can customize the social distancing detection for retail settings reference implementation. We have already demonstrated the installation and default run process in the previous video of this series. Now, let us move to the configuration part where we will show you how to customize this reference implementation based on your requirement. The configuration.env file in the MCSS COVID-19/app directory contains all the necessary default configurations. To start with customizations, first, you might want to provide the application your own video source as input. You can use a video file, live camera stream, or RTSP stream, and as this reference implementation supports multiple sources, you can feed multiple videos as input at the same time. Let's see how we can change the input video. If you are using a video file, first you will need to place the input videos in the resources folder and then specify the path in the configuration.env file. Here, based on the camera angle of the video, you might also need to increase or decrease the sensitivity. With this parameter, you can do the calibration of social distance measuring based on the camera location or angle to get accurate social distancing violation results. Now we save the changes in the code and run the application with the new video. We have also provided provisions for running the application using a live camera and RSTP stream. You will find instructions for the same under optional steps in the documentation. Here is the application output with a different video. Now let us move to the next part, changing the model. If you want to change the inference model or use your own custom model, you can update it from the configuration.env file and make sure you also calibrate the social distance measuring parameter. Here we have used Person Detection Retail 0013, which you can download from Intel Open Model Zoo. And it is completely free to use in commercial applications. If the application you are building is connected to multiple cameras and handling multiple streams, let's see how you can add more channels or input video sources. You can quickly do that from the configuration.env file. Here you can modify num channel and num sources parameters based on your requirements. To add more input sources, add a new line with variable input underscore source 2 followed by the path to the second input, and similarly input underscore source 3 followed by the path to the third input, and so on. You would also need to add minimum social distancing value for other input sources as well. Now let us run the application. Here you can see the changes updated and output with 2 video sources and 12 number of channels. Next, in order to achieve better performance, you can run inference on CPU, integrated GPU, and HDDL or combination of these using multi-device plugin, which is a part of Intel distribution of OpenVINO toolkit. Multi-device plugin automatically assigns inference requests to available computational devices to execute the request in parallel. You can also decrease the input video resolution using this parameter and you will find performance gets better but with less accuracy. Let's run inference on CPU and GPU using multi-device plugin. The format is easy. you will need to just pass the parameter multi with the device names. So here it will be multi:CPU, GPU. We can also change the decode device for video. Let's decode on CPU. Here too, you can use combination of devices using the multi-device plugin. Let us run the application. You can also view the application logs using this command. Finally, extending this application to face mask detection is easy as we have provided provisions for it. You can uncomment these lines of code and use an appropriate inferencing model. This reference implementation is containerized and hence it allows to create consistent and recreatable environments that are isolated from each other and can include dependencies so that it can work in any environment smoothly. In the next video, we will show you how you can visualize this data using a Grafana dashboard.